If you live in an area with common power outages, then you probably have a UPS. This is an uninterruptible power supply. It's effectively a large bank of batteries, and if the power goes out, those batteries can continue to provide your systems with power. This is very common for short-term outages because there's only so much battery available, and you can usually only run these systems for so long. And there are different types of UPS systems that you could use. One is the offline or standby UPS. This is usually the lowest cost UPS and one that's very commonly seen in the home. A standby UPS will always have the batteries charged, and if it notices that the main power is not available, it switches all of the systems over to battery power. This switching happens very quickly, but there could be small amounts of time where no power is available. If you need a power system that's a little more available, you may want to use a line interactive UPS that can provide additional voltage during low voltage levels and provide additional surge protection if there happens to be higher voltage levels. And if you're in the enterprise, you're probably using an online or double conversion UPS where you're always getting power from the inverter side of the UPS. So if you do lose power, there's no switching process that has to take place. A UPS can provide more than simply an additional power source. It may have auto shutdown capabilities, so if it recognizes that there's a power outage, it can tell your computer to gracefully shut down so that you don't lose any of your data. There are also different options for sizing and battery capacity of these UPS systems. You can have a different number of outlets on the back of the system, and you might even have additional connections on the back for phone lines or coax to protect against surges. In the rack itself, you need to have some way to connect all of your servers and components to a power source, and this is usually done by using a power distribution unit, or a PDU. This is a PDU that I use in my studio. This one is a small one that is rack mountable. It has 8 outlets, and I'm able to access this device across the network to be able to turn on or turn off any of these outlets. Many PDUs provide monitoring functions so you can see exactly how much power you're using, and PDUs like this one also have SNMP availability so you can manage it from a central workstation. One problem with the UPS is if the power stays out for an extended amount of time, you will eventually deplete the battery and no longer have power. To have a longer-term power source, you may want to consider using a generator. This is an engine that creates electricity for your local facility, and it usually runs on diesel fuel or natural gas. But with a large enough generator, you could power an entire building and all of the systems inside of that building. In many environments, the outlets themselves will be marked with a color or a marking to designate that those outlets are available if the generator is running. It may take a minute or so to get the generator started and up to speed so that it can provide power for the rest of the building. In the meantime, we may want to use a UPS to provide the short-term power and then switch over to generator power when it's available. In our data centers, one critical piece of infrastructure support is the HVAC. This is the heating, ventilation, and air conditioning system. Our computers create a lot of heat, and we need to make sure that we have a way to cool those to keep everything running properly. Designing and implementing an HVAC system can be incredibly complex. There's a lot of moving parts and a lot of different pieces that need to be integrated into the HVAC. For example, we need to make sure the HVAC is integrated into the fire system. If someone does pull a fire alarm, we need to make sure the HVAC is not sending additional oxygen into the source of the fire. There's also a set of sensors and a management workstation that's used to control all of these HVAC systems. As the temperature changes outside and the environment changes inside of the data center, these management systems will be able to modify the HVAC output. This is one of those critical systems that not only keeps your computers up and running, but also makes the work environment pleasant for all of the users on every floor of the building. We mentioned earlier about the HVAC connecting into the fire system, and having some type of fire suppression is extremely important, especially when you consider all of this electronic equipment that might be in a data center. This is a very large area that you would have to protect against fire, and it's a lot of electrical equipment, so you can't use water to be able to put out these electrical fires. Instead, we would use a series of inert gases or chemical agents to be able to remove the oxygen from the air and suppress the fire wherever it may be in the data center. This is usually kept in a tank in the equipment room, and it disperses the chemical through nozzles in the data center. As we mentioned, this is usually integrated into the HVAC, so we can disable any air handlers if this happens to recognize carbon monoxide or the potential of a fire.